So now we kind of establish, the motivation behind these type of attacks. Uh, my first question is like, how do we prevent them? Like, is there sort of like IP filtering? Because if a
Yeah.
request originate from a certain IP address often enough times, how do we know that's a bad IP address?
Well, only through reputation, obviously. So there's lots of reputation lists that you can use. For example, there's lists that indicate that traffic originates from a data center or an anonymized IP, like Tor exit nodes or VPN services. And you could say, okay, maybe maybe you allow these sources to play, but you do not fully trust them and maybe send them to different game servers than the regular players with normal IPs. But again, if we speak about DDoS, we speak about compromised devices that are real user IPs, real devices, for example, internet routers that just don't know that they are attacking and they are doing the normal service for the users that are using them. So you can work with IP lists and you should work with IP lists because it's the most effective thing that you can do. But this is something that I would consider as a thing that is always changing and requires you to always do some work and evaluation on these IP lists. So it is not a static thing. And again, as I said earlier, I would combine this with some sort of analytics that helps you understand, are there certain IP ranges where the attacks are coming from, and then block these IP ranges for the time when the attack is happening. This would be one thing. Another thing, and there's a lot of things that you can do on the host level already, so you don't need any AWS service for that. So if you're good in IP tables and NetFilter on Linux, for instance. Another thing is, when we talk about multiplayer games, matchmaking. You probably do some kind of matchmaking where you group people together to play on the game servers. And if you have gone through the matchmaking, you probably know who exactly will be on this server. So you could, in theory, allow only the IPs that have been present at matchmaking to connect to the server, and everything else would just be dropped. Or maybe you allow an additional buffer of, let's say, 5 IPs, but the rest would be blocked. So you can narrow that really well down to some extent.
Okay. Another consideration that I could think of is mobile gamers. They use mobile data, and I would think that their IP address would be more dynamic, as opposed
Yeah.
to gaming off of a console PC or console or PC.
Right, right. There's another trick that you could use here. It's, for example, you can enable connection tracking or similar mechanisms on the networking stack of the Linux instance, and then, for example, only allow 10 concurrent connections or a certain number of concurrent connections at the same time. But it would not give a preference to the gamers. So this could also be abused, by attackers, or occupied by the attackers. So yeah, it's kind of hard to defend the UDP port because it has to be open, it has to listen, and the server has to evaluate the packet, because as it has this missing confirmation handshake like TCP does, basically you have to evaluate every packet. What really helps here is, and here we speak about cloud. So if we speak about massive attacks that are not, where a single server is just not capable of handling this, then we have to talk about, okay, what can we do maybe with some resource that has the required bandwidth to handle this. And here we speak about cloud. Here we speak about basically the border of the cloud network. So when you look at EC2, look at security groups, look at network ACLs, or look at the IP tables that you perform the IP table rules that you perform on an EC2 instance, this all happens on the host level. So basically the traffic goes all the way through our backbone, through the network until it reaches that particular instance. What you can do with AWS, there's a service called Shield Advanced, which allows you to deploy elastic IPs to the border of the network. And that means we can put some rules in place for you with custom mitigations that would only allow valid traffic from players at the border of the network. And here we have a much higher bandwidth that any instance could possibly have. And therefore we are much more capable of actually mitigating an attack before it even gets to the game server.
Okay, so yeah, definitely Shield is the AWS service to mitigate against DDoS attacks. However, you mentioned it kind of works on the edge of the cloud. So do we have essentially endpoints on the edge before that traffic is routed to your game server? And is that where Shield kind of function?
No, not really. Shield sits at many places in the AWS network. If we talk about edge, we talk about like points of presence, which we have, if I'm not mistaken, more than 310 currently globally deployed. Shield would sit at every point of presence and then protect your resources. And this is very effective. Let's say if we speak about HTTP workloads that are running via Amazon CloudFront, here you have, I would say, the best possible protection that you can have for web workloads that you can have today. If we talk about UDP or a single server instance, then you still have the Shield protection. In fact, you always, as an AWS customer, have this Shield protection. So whatever DDoS is performed against AWS resources, it will be ultimately mitigated at some point, but not instantly. And if we speak about game sessions, you know, these can last 10 minutes, 20 minutes, maybe half an hour, but often it's not longer. And therefore, every second that you are under attack and experience such an event is a critical thing. So the key to solving that is again, preventing that the unauthorized traffic gets through to the resource. And this is what you do, you know, at the border of the network. So we speak about, let's say, US East 1 region. This region connects via the backbone to the internet. And at this point where it connects, this is the border network of the region. And this is where we can deploy the network ACLs and elastic IPs and the mitigation rules that are very specific to the game use case. But this is something that's not included in the Shield service. It's included in the Shield Advanced service. So it's basically the premium version of Shield, where we can do custom mitigations for you on a very deep level.
Okay, so if I'm understanding this right, Shield Standard is automatically enabled for all AWS resources, and for more customized mitigation, then we also have an offering called Shield Advanced. Is that right?
That's right.
There are games where the session duration is, you know, under 30 minutes. Well, what about persistent world games where the server's always on? Is there a difference in duration between the DDoS attack? You know, if I were to play like a team versus team session, or am I logging into a MMORPG?
It depends, which is the diplomatic answer. So when we, I would not say that this is a technical question. It's more like a question of what does the game look like? What type of game is it? How does it work? How do the mechanics work? And how would a cheater benefit from an attack? And it's maybe something that you didn't plan, you didn't anticipate, so you go live with your game. Maybe it runs well, then overnight it gets popular. It still runs well, but at some point people, like bad actors, figure out how they can gain advantages for themselves, and then they start attacking it. So, but most gaming workloads, which are actually because of people want to cheat, right? We see attacks that are super short timed, maybe minutes, and not much longer, because this amount of time usually is enough for these people to get what they need. And then basically there's no need to further attack that. I mean, of course, you can always have attack that lasts long, for a long period of time. This can happen if, someone is really mad at you, or they want to damage your business really. So it's not then cheaters anymore, but probably like really hackers that have the intention to bring your service down or hurt your reputation. But in gaming, actually, mostly what we see is very short-timed, precisely timed attacks.
Okay, so since the duration of these attacks that are targeted towards game servers are shorter comparatively to other workloads, would you say a good mitigation technique is to just spin up more servers, scale out my compute to handle that DDoS flood, just to like kind of I guess weather the attack, if you will?
Yeah. Well, if your workload can scale, scaling is probably the best thing that you can do to mitigate an ongoing attack. Yeah, but scaling is, I mean, it's a full automation that you're running when you do auto scaling, and you have to be careful how you do the auto scaling, because it's usually fine-tuned to normal user behavior. And if you would experience an attack, this is completely different. Like, you wouldn't expect 1 million users more within 1 minute, unless it's a really successful game. So when you want to scale out an attack, you have to make sure that the scaling also works for these edge cases.
Okay. When I think of scaling, obviously when it's legitimate traffic, if I were a game developer, I scale more servers, mean I have more legitimate players, means I make more money. But if it's illegitimate traffic, and I do already have some sort of auto scaling in place, then I'm just sinking more costs. So it's not just disruption of service to my legitimate players, it's also a increase in costs.
I mean, what's also really cool, this is what I like about Shield Advanced, is of course we help you to protect, we help you to place mitigations, we help you to prepare for DDoS events. But what Shield Advanced also does, it's kind of an insurance if you need to scale out because of an attack. So if you are subscribing to Shield Advanced and you have to scale your EC2 instances to a ridiculous high level just to mitigate the attack, we will reimburse the cost for you. Because Shield Advanced is also a kind of an insurance for your AWS bill.
Okay. Okay, yeah, that's good to know. So Shield Advanced does offer cost protection should you need to scale your resources to weather a DDoS attack.
Yeah.
So thank you very much, David, for your time and speaking with us today.